Electrolysis is the process by which a chemical reaction is generated by passing an electrical current through a solution. There are three basic components needed to achieve electrolysis: a direct current, electrodes, and an electrolyte. The current creates a potential difference between the two types of electrodes used: a cathode, which attracts positive cations, and an anode, which attracts negative anions. This exchange of ions is done through an electrolyte, which is a substance that, when liquid, will conduct electricity. Electrolysis has many uses, but among the most common industrial ones are ore refining and the mass production of chemicals. An example of this refining is the extraction of aluminum from its ore, bauxite. The ions need to be free to move, so it's dissolved in a molten aluminum compound, which has a lower melting point. During electrolysis, positive metal ions are attracted to the cathode, where they gain electrons and form metal atoms. Negative, non-metal ions are attracted to the positive electrode, where they lose electrons and form non-metal atoms. So, positively charged aluminum ions gain electrons from the cathode and form molten aluminum. Oxide ions lose electrons at the anode and form oxygen molecules. A much easier way to showcase electrolysis is by removing the rust from an iron object. Many people actually do this to restore antiques or other rusted iron objects. The metal to be restored is connected to the negative wire, making it the cathode. The positive wire is connected to a sacrificial piece of metal. This is the anode. Rust removal by electrolysis works because rust is basically iron that has gone through ionic bonding with oxygen, i.e., iron that has lost electrons through oxidation. The electric current reduces the rust, turning it into an easy-to-remove black oxide. The release of the oxygen and the separation from hydrogen molecules in the water form bubbles that also help dislodge the bigger rust caps, speeding up the process. All these reactions take place in the electrolyte substance. Its electric conductivity allows the free movement of ions and electrical current. At the end of the process, the cathode will be free of rust, and the anode will be covered in some of the red rust that was not reduced. My experiment. As presented before, electrolysis needs three basic components: an electrolyte substance, electrodes, and a direct current. I used an old wall charger to provide the electrical current. This wall charger converts the grid's AC current into DC. I separated and stripped the wire into its polarities. For the anodes, I used two old pieces of rebar, which only needed to be scrubbed to the bare metal because otherwise it wouldn't work. I connected them with an insulated copper wire. The cathode used was a chopped up old metal clothes hanger. For the electrolyte, I used a solution of water and sodium bicarbonate, also known as baking soda. Washing soda also works. I connected the positive wire to the anodes and the negative to the old coat hanger, which now had the rusted object. In this case, an old wrench, and later a screwdriver. As soon as I plugged in the charger, bubbles started coming out of the cathode. After a while, I could see the rust accumulating on the anodes, and after a few hours, I took the wrench out. It was coated in a black material, which is actually various iron oxides like magnetite. I removed the oxides easily with a metal wire brush. Afterwards, it was completely clear of rust and any other residue. It just had a few small holes where the rust had been deeper due to years of exposure to the elements. It's easy to see the difference between the before and after. The markings on the tool are now easy to read, and the bare metal is exposed. The small amount of residue that remains could be removed with more scrubbing or regular cleaning products. The time needed to derust an object is directly related to the size of the object, the quantity of rust, and the current provided. In this time lapse, taken in the span of around 5 hours, it's easier to see the progress of electrolysis on the cathode. Although the anodes aren't really visible, the change in coloration of the electrolyte is enough to tell their condition. After the wrench, I decided to run the process again with a screwdriver, which actually took much longer. I had to leave it overnight, and it left much more residue, both at the bottom of the tank and in the anodes. Again, it's easy to see the before and after on the screwdriver, and how electrolysis removes rust and leaves only black oxide and small dimples. In a nutshell, rust is iron that has lost electrons, and electrolysis adds those electrons back.